Okay, now I'm here. So I want to go over a few housekeeping things before we get started. First off, this week is going to be kind of more, or it's going to be more compact. Like we're going to go over 8-1 today, 2 tomorrow, 3 on Wednesday. Then I'm going to open up the final. So I have to have the final done by Friday. Like I have to turn these grades in over the weekend because you guys have to actually, I might have to have it on Thursday. I'll get with you on that. But I know I'm going to open it Wednesday and Thursday. So I might have to have it done by Thursday night. They haven't sent us an email yet. I need to be more on top of that. So I'll email our registrar to see when she needs the final grades because, this class, of course, leads into the next 7-week class, which is college algebra. So I've got to get the final grades in so you guys can go on to college algebra. No big deal. Okay. Second, I wanted to go over the point system for our class. If you go to the grade book and you go to, I know you can't see it right now if you're on there, but if you click on the syllabi, you'll see that each point or each test is worth 50 points. Each regular test, I should say, is worth 50 points. I know in the Blackboard system, it gives you like a point value, like, out of 20, but realize I use that as like a percent, whatever percent you get on the test, that's what you get out of 50 for each class or for each test. So like if you made a, 80, so if you got like, what would that be? 16 out of 20 on one of the tests, well, that's an 80%. Well, that means you're going to get 80% of 50 on that test. So that really means you're going to get whatever point that is. So 80, that's 40 points. So I know that's kind of goofy, but Blackboard does like a point system and doesn't do a percent system. You have to like do it on the back end. So it looks kind of goofy. So it's not really about points. It's more about by percentages. So whatever percent you made on the test, that's what you made out of 50 on if you're trying to calculate your grade. That's kind of the best way to do it. Okay.
So I have a question about the grade then. So like the last test, I made 15 out of 20. So actually I only made 15 out of 50.
No, you made 15 out of 20, which is a 75%.
Uh-huh.
So 75% out of 50.
Okay.
I'm not sure what that is. I should know that. That's like a 75% out of 50, which would be like about a 30 something, 40-ish.
So the grade, I have a question though, because the grade I have is a 77. So that's not really what I have. So I might not be passing?
Well, I'm not sure about that. I think another thing Blackboard did was give you an attendance grade. Did it do it for this class?
Yes.
Yeah, and you need to get rid of that. I don't know why it gave you an attendance grade. So I would go through and just look at, so like you said, you made a 15 out of 20. So hold on. Let's do some math. Hold on. Let me get you over here. So if I made a 15 out of 20, that's 75%, right? Now the test is actually worth 50 points, right? It's worth 50 points total. So it's going to be 50 times 0.75. If I'm going to take my calculator out. And I'm going to say 50 times 0.75. Oh, that's 37.5 points. So was that test 5, Letitia?
That was 6.
Oh, test 6. Yeah. I'm a week behind. Yeah. So on test 6, if you're doing point totals, you got 37.5 points for that test. So like if you made, so that was test 6, right? We'll say T6. And let's say you made, I don't know, 13 out of 20. Let's say, did I do any that were 25 or were they all 20?
All 20.
Okay, good. Let's say 13 out of 20. So that's a 65%. But then I'd say 50 times 0.65. So 50 times, so that's 32.5 for test. Let's say that was test 5. And then I would just add these all up and realize each one's out of 50. So like In the end, I believe you got the final is going to be worth 100 points. So in the end, you would have what 400 points total. So when you add all these up, because of course you don't know what you're going to make on the final yet, but that would be out of 50 times 6 would be 300. So when you add all these up, just do that, whatever that number is, divided by 300, and that'll give you your grade.
Okay.
Right, as of right now. That was just a Blackboard issue stuff.
No, baby.
And he or she is intrigued, right?
Yeah, he hears your voice.
Nice. Okay. Any questions about that? I'm going to try to get this stuff fixed for college algebra. So, like, I didn't realize it would be such a thing until a few guys started emailing me about it. And I thought, I've got to go over this. Any other questions before we get rocking and rolling? And I will. I'm definitely opening up on Wednesday. Be prepared to take it Wednesday or Thursday. I'm going to try to see if I can get it open to Friday. But this is usually we have a whole week off in between. But remember, we started a week late. So they took away the week in between, which makes it tough getting grades in. So that part's going to be kind of goofy this semester. Okay, so let's start on 8.1. 8.1 is really two sections. Okay, 8.1, the first section is on the square root property. And then the second part's on completing the square. Let me see if I can kind of. Okay. So first we're talking about the square root property. And we have to know it to do completing the square, so that's why your book goes over it first. The square root property is pretty straightforward. If you know that something squared equals b, okay? So if you got a, it's squared, it equals b. And if you're trying to solve for a, you can take the square root of both sides. But when you do that, you have to attach a plus or minus, okay? You have to attach a plus or minus. So you wind up with a equals plus or minus b. Okay? So let's say we've got something really basic, like x squared. We'll kind of see why this is true. X squared equals 25, okay? You've got an equation now. X squared equals 25. Remember, it's a quadratic equation, right? In the past, before chapter 8, we solved all of these by factoring. But from here, in chapter 8, we're going to go over how to solve these with if they don't factor, or maybe just quicker, different ways of doing it anyway. So I'm going to take the square root of both sides, right? But when I do that, I'm going to attach a plus or minus. Now we know the square root of 25 is just 5. So this becomes plus or minus 5. Now really what we have is we have two answers. And in your book, I'm going to see, yeah, a lot of times they separate them with brackets. The squiggly brackets, they'll say -5, comma 5. So that's not a coordinate. That's called set notation. It means x can be anything given it's -5 or 5. And it kind of makes sense, right? 5 squared is 25, right? But also -5 squared would also be a positive 25. That's why we have to have the plus or minus. That's why we have to have the plus or minus. And then the first few examples I'm going to do today in the first part of 8.1, it just makes this a lot harder. The book just kind of goes into some deeper, kind of harder examples as we go. So if we looked at something like, okay, well, let's go through like how you would actually solve these. Let's say we've got x squared, let's say 2x squared minus 100 equals 0. So if I want to solve using the square root property, call it square property just to save some space. if I wanted to solve using the square property, the square root property, the first thing we have to realize is that we have to be able to get whatever is squared by itself. And by that, I mean, there's not another variable. Notice there's not an x here, right? Just an x squared. So because there's not an x and just an x squared, I would look at using this way of solving, okay? In contrast, if we had something like, let's say, 2x squared plus x minus 10 equals 0. If I've got something like this, I would not use the square root property because this x is there, okay? I could get x squared by itself, but whenever I solve for x squared, it's not going to get just a number on the other side, okay? So I wouldn't use it for this type of equation. So let's go back to here now. I'll show you what I'm talking about. So I'm going to get x squared by itself, so I'm going to add the 100. And I get 2x squared equals 100, right? Then I'm going to divide the 2. And I get x squared equals 50. And notice, that's step 1. Isolate square. Remember how in the other section we isolated the square root? Well, in this one, we're going to isolate the square. And notice we have just whatever is squared equal to a number. We need that to happen, okay? We need a number to be on the other side. Now, this might look goofier. We'll see some examples that this is more complex. But on the right-hand side, or the sign that doesn't have the x, it needs to be just a number. Okay, so now we're going to do the square root property that we just learned about. Okay, so I'm going to take the square root. I'll use blue here. I'm going to take the square root of both sides. But when I do that, I'm not going to forget the plus or minus. So I get x equals plus or minus the square root of 50. And notice we've solved for x, right? In this one. In other examples, it's going to be a little more complex. So I'm going to add a step here that we don't have to do for this equation. But I'm going to say solve. Well, we'll have to simplify. Let's say solve and simplify. Solve and simplify. So for us, we don't have to solve it. X is already by itself, but we need to simplify the square root of 50. We've been doing this a lot, the last few weeks. So let's look at 50. It's 10 times 5, 2 times 5. I can pull a 5 out. The 2's got to stay, right? So x equals plus or minus 2. Oh, I wrote that down wrong. X equals plus or minus 5. Square root of 2, right? Plus or minus 5 square root of 2. So now, again, it's one of those things where if this was a written test and it was a normal semester, I would take this as an answer, but your book is going to write it like this. It's going to be like -5 square root of 2, comma 5 square root of 2. Okay? It's going to write it like that because that's the true math way of writing this. Now, you're more than welcome to check these. But I'm going to keep rocking and rolling because this lecture might take a little longer than some previous ones just because there's really two main concepts going on. Okay? Any questions, comments, or concerns other than, yeah, let's just see 3 or 4 of those that all look kind of different. Okay. So let's see here. Let me find another one that looks a little different that we're going to have to solve a little bit for. So let's say we had x plus 1 squared minus 2 equals 9. Why not? Now I'm going to follow those same rules. Okay? Same rules. I'm going to isolate the square. Now what's different is the square isn't just a variable here. Okay? The square is a binomial. So I've got to get this whole thing by itself now. Okay? I've got to get this whole thing by itself. So I'm going to add the 2. And I get x plus 1 squared equals 11. Then I'm going to do the same thing. Once this thing's by itself, and look, notice I have a number over here. There's no x value. I've got just a number. I'm going to do the square root property. I'm going to take the square root of both sides. And I'm not going to forget the plus or minus. It's a very common issue. And notice what happens is this square root of this squared, it all goes away. So you're left with x plus 1. So really, the reason we use the square root property is to get that square to go away. We got that to happen. And on the right, though, we've got plus or minus the square root of 11. Now notice, so we've isolated the square. We did the square root property, right? Both sides. And then we've got to solve and simplify. So this one we do have to solve. We've got to get this x by itself, right? So I'm going to move the 1 over. Now we know we can't add a 1 in a radical. So we're just going to put the 1 in front. Okay, we're just going to put the 1 in front. Now, at this point, too, we need to see if we can simplify 11. 11 is a prime number. It is not going to simplify. Okay. Yeah. 11 is a prime number. It will not simplify. So we're done, actually. So it's going to be written like this. -1 plus the square root of 11. -1 minus the square root of 11. Okay. That's going to be our two solutions. Okay. Question. Okay, let me give you 2 examples now. I'm going to say, let's say we had 3x squared plus 36 equals 0. So that's going to be, we'll call that A. And B, we're going to go with x plus 2 squared minus 1 equals 24. That's a 24, guys. So I want you to try those 2 real fast. See what you get. These 2 are really good examples. Okay, let's rock and roll here. First one's a lot like that first example. I've just got to get x squared by itself. So I'm going to move the 36 over. So I get 3x squared equals negative 36. Divide the 3, and I get x squared equals negative 12, right? Take the square root of both sides, and I'm going to kind of do this over here on the here. So if I took the square root of both sides, I'd have to have the plus or minus, right? Negative 12. So I get x equals plus or minus the square root of negative 12. So now I've got to simplify this guy. Well, it's negative. I know I've got to take an I out, right? The 12, let's see here. 12 is 6 times 2. 3 times 2, I can take a 2 out as well. 3 is going to stay over. So I get x equals plus or minus 2i. So the 2 comes out. I comes out because it's negative. Square root of 3. Now, I'm going to just box in this answer. You guys realize it'll be plus 2i squared 3 minus 2i squared 3. Okay, and then the b one. So now I've got to get this by itself. So I'm going to add the 1. So I get x plus 2 squared equals 25, right? Take the square root of both sides. Don't forget the plus or minus. So I get x plus 2 equals plus or minus 20, square root of 25, right? Now I'm going to move the 2 over. So, subtract the 2. Now, the difference on this one is you could take the square root of 25. Of the 3 examples we've done so far, the radicals had to stay because it didn't simplify out completely. So if it simplifies out completely, you've got to do the basic math, okay? So it winds up being x equals negative 2 plus 5 and x equals negative 2 minus 5. That's the plus or minus here, right? So if this thing has a nice square root, you've got to split it up and keep going. So negative 2 plus 5 is 3. Negative 2 minus 5 is negative 7. These are a lot easier to check your answer if you just want to. If you put 3 in, 3 plus 2 is 5, squared 25, minus 1, 24. Negative 7 plus 2, negative 5 squared, 25 minus 1, 24. So they both check out. Okay. Questions on that one? Okay. Yeah, let's go over one that's a little more complex. It won't really pop up in the next, or the thing we're going to cover in 8.1, but it's going to come up in like 8.2 and 8.3. So what if we had one that looked like this? I'm going to steal this from the book. Excuse me. 3x minus 1 squared equals negative 4. 3x minus 1 squared. It's not that bad. The solving part, I can tell because there's a coefficient here. Solving part is going to be a few more steps. But let's go through this and solve it. I don't have to isolate the square. It's already done for me. Negative 4 is over here by itself. So I'm going to take the square root right off the bat. So I wind up with 3x minus 1 equals, and you know what? I'm going to just simplify this here. You don't have to wait till the very end to simplify it. I know the square root of 4 is 2. Now it's negative, so this winds up being 2i, right? This winds up being 2i. And now I've got to get to this guy, okay? So the first thing I'm going to do is add the 1 over. I can't add these, right? We have a real number and an imaginary number. They don't add together. I didn't really go over that in that chapter, that 7.7 section, but real and imaginary numbers don't add together. They're really like unlike terms. You can treat them that way. So it becomes 1 plus or minus 2i. Okay, remember this was like that complex number, how it was the real part and the imaginary part, the a plus bi. And then I'm going to divide 3. Now, when I do this, I'm going to divide everything by 3. So that's how your solutions are going to look. 1 plus or minus 2i over 3. Now, again, it's going to look like this. 1 plus 2i all over 3 and 1 minus 2i all over 3. Okay? So a little more complex, but it's just because that coefficient at the very beginning, that 3, look, when you took the square root, still there, add the 1, and then you had to divide everything by 3. Okay? Not as important for what we're about to do, but it is what it is. Okay? Okay. Questions before we get to the actual completing the square. Are we good? So what happens is the second part of solving in completing the square, what we're about to do is just this. Our goal is to get it to look like this, and then we know what we're doing. Okay? So completing the square. First, I'm going to do kind of a little exercise, okay? And the exercise is on the perfect square trinomials. And I want you to follow along here because it really, it works. It's only going to work, really, if you follow along with me. And the first thing I'm going to do is I'm going to write 3 different perfect square trinomials, and we're going to try to find a pattern. Okay, this is what our brains are best at. So let's stick to some kind of basic examples. Let's say x squared plus let's say 8x plus 16. Okay, this trinomial 8x squared plus 8x plus 16, it factors into x plus 4 squared. Okay, that's our first example. Okay, that's our first example. So now let's do another one. Let's say we've got x squared minus 10x plus 25. It factors, I mean, if you want to do the factoring, that's fine. Look, -5 times -5 gives you, adds up to -10. So it winds up being x minus 5 squared. Okay. And I'm going to do one more, and then we're going to kind of fill in some blanks here. Okay, so let's say we had x squared. These are a lot easier when they're even. Let's say 14x, 49, and this would factor into x plus 7 squared. Okay, so those are our 3 examples, and we're going to try to see a pattern here. And I'm going to put in like boxes, and I know it sounds goofy, but we're going to fill in the box based on this pattern that we see. Okay, so I'm going to ask you this question. I want you to put the answer, what you think the answer is, in the chat box, okay? So I'm going to give you another one of these examples. Look, we're sticking to perfect square trinomials. These fit a very specific pattern. X squared plus, let's say 6x. I want to know what needs to go in that box to make this a perfect square trinomial. Okay, so if you look at the pattern over here, look, each one of these relationship together, I should say. What do you think needs to go in that box? It's okay if you get it wrong. Okay, Amanda says 9. Janie, 9 as well. You can go with 9, Kyle. Are you gonna? Kyle goes with 9. I mean, democracy, we've got 9. Okay, Amanda, I'm going to ask you if you can talk. How did your brain see 9?
3 plus 3 is 6, so.
So
that's the way I was looking at it, is 9 when you do the factoring, you get 3 and 3, which gives you a positive 6. So x plus 3 squared.
Oh, perfect. We'll time out there. So x plus 3's got to go here, right?
Uh-huh.
Okay. And then what has to go here? You're right.
9.
Booyah. Okay, sweet. Perfect. You see the pattern. Okay. I'm going to go over like the more mathy pattern here in a minute, but you don't have to know the little formula if your brain sees it. Okay. And you're completely right, Amanda. Completely right. So, okay, let's try this one then, guys. I'm going to give you a few more. Let's say we got x squared minus, let's say minus 2x. And so I want you to fill these in. Actually, fill both. Fill the box in and fill the parentheses in. And then let's do x squared plus 20x. So do the box and the parentheses. Okay, I'm gonna tell you this one's kind of trickier. I'm gonna start down here. So here's how my brain thinks of it, and it's exactly how Amanda's was thinking, just a little different because instead of saying that like, oh, it's 10 plus 10, I think of it like 20 divided by 2. Okay, so I'm gonna take this middle number. When you divide it by 2, you can see that you get whatever's inside the parentheses, right? So for this one, it would be x plus 10, right? Positive 20 divided by 2 is 10. And like it keeps the sign, right? Like negative 10 divided by 2, negative 5. And then, yeah, the 10 squared. So the 100 is going to go right there. Okay. 100 is going to go right there. So then I'm going to do this one the same way. If I divide negative 2 by 2, I get a minus 1, right? X minus 1. And then when you square it, you get a positive 1 there. Because negative 1 squared is a positive 1, right? Negative 1 times negative 1. Great. Now I'm going to tell you, these are all nice. And I only do completing the square whenever this b value is even. Okay. Notice we call that the b value. The a is the coefficient here. It's just a 1. Like that would be a. This would be b. This would be c. We'll formally like talk about that one tomorrow, actually. But when this, I only use completing the square when the b value is even. If it's not, I use a different form of solving, okay? Because all of chapter 8 is going to be solving quadratics like this, okay? It's going to just be solving quadratics. So let's get to the actual like solving part now. Now I want you to remember this. It's going to pop up in the middle of the solving. Hold on. Get the piece of paper out. So let's say I've got something. I'm going to steal one from the book that's not crazy looking. Yeah, okay. Let's say I've got x squared. I'm not really stealing it from the book, but x squared plus 6x plus, let's say 1 equals 0. And I'm going to talk about this for a second because look, before, or the only way we've talked about solving one of these is by factoring, right? And to factor this, you would need 1 times 1 to add up to 6, and it's not happening, right? You can't multiply 2 numbers to get 1 and have them add up to 6. So what this means is that this quadratic does not factor. Okay, we can't use what we learned in section, I think it was 5.6 or 7, I can't remember now. We can't use that knowledge to solve this equation. So we're going to have to learn new ways to solve these. And look, when you get to college algebra, you're going to have to know how to solve a quadratic. It's going to have to be just kind of a habit. So, and that's why I put this section right before college algebra starting. Okay, so it'd be fresh when you got into the college algebra class. So the first way we're going to go over solving these is completing the square. Okay. And my only indicator on when to use completing the square or when I do it again is if that middle number right there is even. If it's even, I'm going to have the green light to do completing the square. And once you get completing the square down a few times, you're going to see it is pretty easy. It takes a little bit of time though. It's one of those where it takes a little bit of practice and then it's just kind of easier to do. Let me go over the steps. And I know this sounds kind of goofy. This first one's goofy. We're going to take, actually, let's use the blue. We're going to take the constant and we have to move it to the other side. Okay. But we have to do something when we do that. Okay. Move constant, the number without the variable, to other side. Now, when you do this, this is the goofy part, and it's just how I teach it. A lot of people online teach it the same way. Some teach it different. But when you move the constant to the other side, add a box to both sides. I'm going to show you what that looks like. So I'm going to move the 1 over. Now, when I do that, of course, it's going to be -1 on the other side. So it's x squared plus 6x plus, now the box goes where the 1 was, okay? And it equals -1. Remember, we moved the 1 over. Subtract the 1 on both sides. Plus, now look, it's an equation. If you add something to one side, you have to add it to the other. Okay? So 1, move constant to the other side and add a box to both sides. Boom, bingo, we did that. Okay? Step 2 is going to be what we just did. That exercise we just went over, I'm going to call it create perfect square trinomial. But I want you to be cognizant that whatever we put in this box on this side has to go in the box on that side. Okay? It's an equation. Whatever we do to one side, we have to do to the other. So now going back to our example, remember for this box, if we were going to make the perfect square trinomial, we really divide the 6 by 2. And then we square it. So the 9 goes here, but a 9 also has to go here. Okay? And notice now, if you add these together, you get 8. Look, we have a square root property example, the one we've been doing so far, right? So what we've done is we've manipulated a nice kind of basic quadratic into a solved by square root. By square root property. Kind of neat, okay? So we manipulated a kind of a basic quadratic into a, hey, all we have to do now is take the square root of both sides. Don't forget the plus or minus, right? And then solve it out. Any questions on this one other than, okay, yeah, I need to see like 4 or 5 more of those, right? Okay, so let's take the square root of both sides. Remember, do not forget the plus or minus. So we get x plus 3 over here. On the right, we get plus or minus the square root of 8. I'm going to have to simplify that. I'll do it after I move the 3 over. X equals -3 plus or minus the square root of 8. 8, that's like 4 times 2. 2 times 2, lots of 2's. I can take out 2 of the 2's, so 1's got to stay, or 1, 2's got to stay under. So we get x equals -3 plus or minus 2 square root of 2. So that's just like, I mean, from here down is just an example from the first 3 or 4 that we did. Now, I'm going to write it like the book does just because your homework's going to look like this. It's going to say -3 plus 2 square root of 2 and -3 minus 2 square root of 2. Okay? So move the constant to the other side. But when you do that, you've got to add a box on both sides. Then we're going to create the perfect square. So I'm going to think of what do I need to, the parentheses and then what's got to go in the box. Okay. So let's do another one of these. I'm going to give you an example, see if you can do it without without me really.
I have a question on that last one real quick.
Yep, what's up?
Do we not simplify that any further?
No, look, you can't add an integer and a radical, right?
But I guess what I mean is the -3 and the 2.
No, that's not a 2. It's a 2 square root of 3. That's like saying, no, I'm glad you asked me this. That's like saying, could we add -3 plus 2x?
Okay.
You see that? How like we couldn't add the -3 and the 2 because the 2 is really a coefficient for the x. So the same thing down here. We couldn't add this 2 to this 3 because really the 2 is a coefficient to the square root of 2. That's one of those things, Amanda, where your brain's kind of deceiving you.
Yeah. Okay, that was my only question.
Yeah, no problem. And that's a super common question. And it's again, it's because our brains. Okay, so I want you to try this one. Let's see. Let's see if I can. Man. Okay, this is number 50 in the book. So 50. You get x squared minus 10x plus 2 equals 0. So try that one. X squared minus 10x plus 2 equals 0. Okay, I'm going to start on this one. And I'm going to kind of follow the steps. Move the 2 over. But when I do that, I've got to add a box on both sides. Okay? Very common to only do the box on one side, not both sides. And then I got to think, how am I going to make this a perfect square? Well, I divide the -10 by 2. I get -5. I square that, I get 25. All right, so I've got to add 25 on both sides. -2 plus 25, that's 23, right? Hey, so now I'm just doing what I did before. So take the square root of both sides. This is x minus 5 equals plus or minus the square root of 23. 23 is a prime number, right? So there's no way that I can simplify it. So I'm just going to add the 5 over. We get x equals 5 plus or minus the square root of 23. So we wind up with 5 plus the square root of 23. 5 minus the square root of 23. Okay? 5 plus the square root of 23 and 5 minus the square root. Questions about that, guys? Seeing this pattern? Okay, let's do one. Let's kind of kick this up a notch. But well, how would you work this with an odd? And you're going to see real quickly why I don't do odds with completing the square. And you don't have to either, okay? Look, if you see an odd question or if one pops up in like section 8.1 that I give you today, you don't have to work it. You can skip over because we'll go over some more here in a little bit. But I want to show you why or what happens when you have an odd issue. Let's look like number 44. So we've got x squared plus 3x minus 2 equals 0. Okay, this is number 44 in the book. So first thing, I'm going to add the 2 over. So we get x squared plus 3x plus the box equals 2 plus the box. Okay. Now, I've got to make this perfect square, right? Now, remember, inside this, so like if we go back to this last example, inside of the parentheses, it's always the middle number divided by 2, okay? If you go back and look at all the examples, you'll see it's the middle number, the b value, divided by 2. Well, this one's not divisible by 2, so we have to write it as a fraction. 3/2, okay? And then whenever we got this number, we squared it and put it in the box. So we take this 3/2, we square it, and it goes inside of our box. That's the pattern, which is real easy whenever b is a nice even number. I'm going to square 3/2. Remember, if you square a fraction, you have to square the top and bottom. So this winds up being 9/4. So 2 plus 9/4, I'm going to do on the side over here. 2 plus 9/4, that's going to be 8/4 plus 9/4, right? So that becomes 17/4. So 2 plus 9/4 winds up being 17/4. Your calculator can do that if you just don't want to deal with fractions. So now I'm going to take the square root of both sides. Do not forget the plus or minus. So I get x plus 3/2 equals plus or minus. Now I've got to take the square root of this fraction. Now we know if you take the square root of a fraction, got to do the top and the bottom. So this winds up being the square root of 17 over. Now we could take the square root of 4. That's just 2, right? Can't take the square root of 17. Move the 3/2 over. So you get x equals negative 3/2 plus or minus the square root of 17 over 2. Now look, what's kind of neat, and this does happen every time, these denominators will match. So that means you can write them together as 1. So this becomes negative 3 plus or minus the square root of 17 all over 2. Okay, this can be written like that. Okay, it combines together because we have the same denominators. Just be careful of the sign, like that -3 that goes in front of the negative up top, and then the plus or minus just goes in between up top. So that's really our 2 solutions. If we do the squiggly brackets, -3 plus the square root of 17 over 2, and -3 minus the square root of 17 over 2. Okay? That's a horrible squiggly bracket, but it is a squiggly bracket. Okay, so you kind of see why I'm not a big fan of doing these whenever, and the whole reason this happened is because that middle number is odd. And I'm going to assign some today that are odd. You don't have to do those. You can just do the ones that are even and you'll be fine. I say even, the b values are even. Okay, the b values are even. Okay, let's do, you know what? I totally forgot about this. Kind of mad at myself right now. Give me 1 second to find one that I like. Well, I'll make one up. So let's say we've got 3y squared minus 12y. Let's say plus 6 equals 0. I just totally whiffed on this part of completing the square. Notice every example we've done so far, the x squared has been by itself. Okay? This one, the y, I mean the square term, the y squared, is not by itself. You have to force it to be by itself. So to do that, you have to divide it away. Okay? You've got to divide it by everything. So because the y squared has to be by itself. So what happens if this turns into y squared minus 4y plus 2 equals 0? So I want you to try this one now. Complete this one. It's got a nice even middle. Complete that one on your own. Okay, so let's see here. So I'm going to move the 2 over. And I get y squared minus 4y plus the box, right? Minus 2 plus the box. Then I'm going to say y. Now divide the 2, so that's minus 2 squared. That means a 4's got to go into both those boxes, right? So divide it by 2 and square it. So this equals 2. Take the square root of both sides. Do not forget the plus or minus. So you get y minus 2 equals plus or minus the square root of 2. Add the 2 to the other side. You get y equals 2 plus or minus the square root of 2. Okay? So if we have a number out front, you just divide it into everything on the first step. Okay? And you'll see that in the homework. I stole that one. No, I didn't steal from homework, but you'll see it in the homework. So if this y squared, if the square term's not 1 by itself, just divide that number into everything. Okay? Questions? We got done a little earlier than I thought. Okay, so for homework, so this is page, starts on page 595. 1 through, no, there's gonna be a gap here. Yeah, 1 through 25. I'm just gonna assign the odds. And then 39 through 69, but these are just odd. So all these odd. Okay. And I'll tell you, if you can't get all of it done, that's fine. It's not these 3 sections don't really like build up to each other. It's more about, excuse me, it's just more, they're kind of 3 separate sections. The next 2 are actually kind of together, but not this one. Okay. You guys have any questions? Good. Straightforward. Okay, great. I'll see you guys. I'll stay on here for a little bit, but I'll see you all tomorrow. And I'll get that information about the final. I should have done that before now. I wasn't even thinking. I'll get that for you as soon as possible.